Imagine, just for a second, that you're standing in the middle of a frantic, high-stakes financial trading floor. The clock is relentlessly ticking down, screens are flashing, and literally every split-second decision you make determines if you walk away with a massive profit or lose the whole shebang. That intense pressure cooker environment, that is exactly what sitting down for your Cambridge IGCSE Physics 0625 exam feels like. You've got a strictly limited amount of time and a fixed number of marks up for grabs. Your goal, your only goal, as a strategic candidate is to invest your time where the marks are highest. So today, we're going to master one of the most notoriously misunderstood areas in the entire syllabus, efficiency and energy transfers. And look, this isn't just about memorizing some formula. It's about learning how to trade your knowledge for absolute maximum marks. Okay, here is a massive examiner alert straight from the Cambridge Principal Examiner reports. They literally said, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. I really need you to internalize this, because this is your ultimate grade-saving safety net. Let me show you what I mean by introducing two pretty typical students, Alex and Sam. So Alex is our overpreparer. When Alex sees an efficiency question, they completely overload the page with raw physics facts, writing this massive, chunky paragraph about thermodynamics, but with absolutely zero analytical structure. And then we have Sam. Sam is the rusher. Sam just looks at the numbers, punches them into a calculator, spits out a final answer of, let's say, 45%, and just writes that single number down. They completely rush past the command word requirements. Now, if that 45% is even slightly off because of a tiny calculator typo, Sam gets 0 marks. Nothing. Not a single point. But if Sam had just written out the mathematical process, the examiner could award method marks for the correct underlying physics. The process is literally just as valuable as the destination.
Which naturally brings us to a huge question. Why do so many students completely blank when it comes to evaluating efficiency and drawing conclusions? One phrase, cognitive overload. In the heat of the exam, when that pressure is on, candidates just panic. They stare at a complex energy transfer diagram or some dense data table, and their brain just tries to dump every single piece of physics knowledge onto the page. But here's the secret. Cambridge examiners are explicitly targeting distinct cognitive domains here. They want your knowledge, sure, but more importantly, they are looking for application and analysis. The whole assessment framework rigorously prioritizes analytical depth over superficial breadth. You can't just list facts. You have to evaluate the evidence and draw justified conclusions based exactly on the command words in the prompt.
Section 1. Core Concepts and Formulas.
Okay, to win the game, you first got to know the rules, right? And in physics, the rules are written in math. The two pillars of this topic are pretty straightforward. Percentage efficiency equals the useful energy output divided by the total energy input, and then you multiply the whole thing by 100%. Or, alternatively, the useful power output divided by the total power input multiplied by 100%. Now, anybody can memorize these equations, but top-performing students, they exhibit a deeply connected conceptual understanding of these exact equations that easily transfers to completely unfamiliar contexts. For instance, if you're suddenly hit with a question about an experimental electric motor lifting a heavy load, you need to instantly recognize that the useful energy output is actually the gravitational potential energy gained by the load, while the total energy input is the electrical energy supplied to the motor. Understanding the relationship between these variables, rather than just memorizing the letters, is exactly what elevates your answer from an average grade to a top-tier score. Before we continue to break down the exact methodology to secure those top-tier scores, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2. The standardized sequence. Let's see how this works in practice. Now, what's really interesting about this slide is how examiners actively award method marks for the process itself. They don't just want the right answer, they want to see the standardized sequence. If you follow their preferred structure, you are practically handing them the highlighter to mark your paper correct. Let's walk through this 5-step sequence. Step 1. Identify key elements. Extract the useful energy and total energy from all that messy text. Step 2. Apply relevant principles. Write down the correct efficiency formula before you do literally anything else. Step 3. Execute analysis with clear working. This is non-negotiable, folks. Write out the substitution of your numbers crystal clear. Step 4. Verify results. Does an efficiency of 120% make sense? No way, because energy cannot be created. If your answer is over 100%, you've definitely flipped the fraction. And Step 5. Present in appropriate format. This means proper headings, correct terminology, appropriate units, and clear annotation. The presentation of information and efficiency follows strict conventions. If you don't use that percentage sign, you bleed marks. It's really that simple.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade bounders. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 3. The Trap. Top Examiner Warnings. Let's take a quick look at the dark side of the exam paper. Here are the top 3 mistakes where students unknowingly bleed marks year after year. First up, answers are way too vague. When examiners ask you to explain why a machine isn't 100% efficient, writing energy is lost gets you a big fat 0. Energy is never just lost. You've got to provide specific details, like energy is dissipated to the surroundings as thermal energy due to friction. Second, forgetting to check format and presentation. Things like leaving off units or rounding incorrectly. And third, answers are not specific to the context given. If the question is specifically about a wind turbine, please don't give a generic answer about a car engine. You have to mold your knowledge to the specific scenario they've provided. Always remember, the assessment objectives demand analytical depth. Let's do a live Find the Flaw exercise together. Take a look at Alex's flawed answer here. The machine is not efficient because energy is lost. It is 40% efficient. Notice how it's just horribly vague and completely lacks calculation steps? Now compare that to a perfect PEEL answer. PEEL stands for point, evidence, explanation, link. Point. The motor has an efficiency of 40%. Evidence. 200 joules useful output divided by 500 joules total input times 100% equals 40%. Explanation. It is not 100% efficient because 300 joules of energy is dissipated as thermal energy due to friction in the motor's bearings. Link. Therefore, the majority of the electrical energy input is not converted into useful kinetic energy. You see the difference there? The perfect PEEL answer provides specific context, clear formulas, and justified reasoning. That right there is exactly how you turn red marks into green check marks.
So the crucial point is that you need a solid way to remember this under the pressure of the exam clock. Here is a super quick, easily digestible memory hack for exam day. FPC, Format, Precision, Context. Format. Did I show my working and include the correct units? Precision. Did I calculate accurately and avoid super vague terms like lost energy? Context. Did I directly address the specific machine or scenario given in the prompt? Mentally run this FPC checklist every single time you finish an efficiency calculation.
Section 4. Deconstruct, solve, and evaluate.
When you finally get to those tricky final questions on the paper, the ones worth 4 to 6 marks, you are no longer just calculating, you are evaluating. Higher-order assessment objectives demand that you evaluate alternatives, compare approaches, and make justified recommendations. You absolutely must deconstruct, solve, and evaluate. First, identify the given information. Break that complex physics data source into logical steps. Then, solve systematically using your efficiency equations. Always check for reasonableness. And finally, step 5, make justified recommendations. If the question asks which power station is better to build, comparative analysis requires identifying similarities and differences. You have to use comparative connectives like whereas or however. Support each comparison with your calculated efficiency evidence and draw actual conclusions about the relative importance of these factors. You also need to identify the limitations of the data, like are there assumptions made in the model. This higher-order critical analysis is exactly how you secure those critical top-tier marks.
Okay, let's pull all of this together into your ultimate 3-rule physics answering system cheat sheet. Rule 1. Command word decoding. You must extract the core requirements accurately. If it says calculate, show the numbers. If it says evaluate, show the pros, the cons, and a solid conclusion. Rule 2. The PEEL framework. Structure your written responses with point, evidence, explanation, and link. And Rule 3. The time management matrix. Treat your exam like that high-stakes trading floor we talked about earlier. Invest your time where the marks are highest. Do not spend 10 minutes agonizing over a 1-mark multiple-choice question when there is a beautiful 5-mark efficiency calculation waiting for you on the very next page that you can easily deconstruct and solve using method marks.
I really want to emphasize the true power of what we've just covered here. 2 grade boundaries. Look, students who actually implement these exact physics strategies, the ones who show they're working for method marks, who use FPC, who structure with Peel, they see an average improvement of 2 full grade boundaries. Let that sink in for a second. That is jumping from a C to an A, or from a B to an A star. But this massive transformation only happens if you practice consistently and actually apply this structured reasoning to past paper questions over and over again.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Now, I want to hear from you. Drop a comment below with your target grade for physics and the biggest challenge you're facing right now. Our team responds to every single comment. We are here to help you navigate this trading floor and secure those top marks. Like and share this explainer with a study partner who needs to master efficiency. Ace the Exams. Your Cambridge success starts here. Keep analyzing, keep calculating, and I will see you in the next masterclass.